Alright, Algebra 2, let me tell you something again. Now this is Mr. Ray C, rap star, you know how it is. Let's talk about compositions of functions, okay? Let's see one of the things that we've been talking about. Okay, I don't know what I'm saying, so let's just get started here. Alright, everybody. So we're talking about compositions of functions. We want to be able to prove whether two functions are inverses of each other's, and we're going to use a strategy called composition. So one of the ways that we're going to learn to do that is we're first going to maybe look at quick refresher, and then we'll look it through of what that actually means. Alright, so alright, well, if I told you to do this right here, solve for f of 2. Alright, what would you do? Well, remember, this is the number, this is our input. Alright, so whatever number I have here, I'm going to replace the x. Alright, so I replace it. So if I have this, I'm going to have equals 3 parentheses. I'm going to replace it with 2. And we're going to get plus 2. So we're going to get f of 2 is equal to, alright, what's 3 times 2? Well, that's 6 plus 2. And so we're going to get f of 2 is equal to 8. Alright, what if I told you to find g of 8? Well, let's plug that into our function, right? This is our input. Remember, anything inside our parentheses is our input. So let's go ahead and plug that in. So here we have 8 minus 2 all divided by 3. So we're going to get g of 8 is equal to 8 minus 2 divided by 3, which is equal to 8 minus 2. Well, that's just 6 divided by 3, and then 6 divided by 3 is 2. So g of 8 is equal to 2. Alright, well, if you notice here, in this problem here, whenever we plugged in 2 into our function, when we plugged in 2, we got 8 as our answer. In this problem here, when we plug in 8 in this potential inverse equation, our answer is 2. Alright, so if you notice, these two equations they are inverses of each other, and basically, like we talked about, inverses, they undo each other. So in this function here, if we plug in 2 and we get 8, well, if we plug in 8 into here, we should get 2, right? What goes around comes around. All right, so basically inverses do the opposite of what the original function did, right? If you put in 2, it comes out 8. In the inverse function here, we put in the 8, we should get back to 2. We're going back to our starting point. All right, so what goes around goes around goes around all the way back around. Justin Timberlake, I wrote the song for him, so this is a part of why it makes sense. Justin Timberlake song. All right, well, let's actually use composition, and what that means is, all right, and one of the ways that we're going to do this is, well, let me just rewrite our equations real quick. We have f of x is equal to 3x plus 2, and we have g of x is equal to x minus 2 divided by 3. All right, now one other thing is, remember, and then we're going to try to piece in a bunch of things that we have kind of learned in our class so far. All right, well, I'm going to graph this function here. So it looks something like this. Remember that when we are making the inverse of a graph, it's going to reflect over the y is equal to x line. So I'm going to write that down. So it should reflect over this line, and we should get something that looks like this right here. It should be the same distance, right? So I'm just going to maybe try to make it a little bit more accurate. All right, that looks a little bit, obviously you can see what I'm trying to do. I'm just trying to make sure the distance looks the same. There we go. All right. So the distance from here to here should be identical, right? Because they're inverses. They're reflecting over the y equals x line. All right. So basically, this here is the y is equal to x line, right? Well, if this is my function, my original function, let's say this right here, 3x plus 2. All right. And I was to take this function and plug it in to my original function, I'm undoing each other, right? So if my original function moves over here, well, if I plug in the inverse, if I do the inverse, I do the opposite of what it did. If I do the opposite of what it did, it should go right back to our starting point, which is y is equal to x. All right, so that may seem kind of intuitively difficult to understand, so let us actually go about doing this. All right, so what composition means is, all right, well, let's go ahead. If I have f of, we're actually going to plug in g of x, the entire function, into my equation. Okay, so remember, just like before, so g of x is this right here, right? So I'm going to write this down below here as f of x. I'm going to use a different color so that we can kind of make sense of this. X minus 2 divided by 3. Okay. All right, now we're going to get equal to 3. I'm going to put parentheses. This entire thing is going to replace x. It's going to replace, because that's our input, right? Anything that's inside our parentheses is we're replacing it with x. We're replacing the entire thing with our input. Just like before over here, when it was 2, we replaced the x with a 2. All right, so we're doing the same thing, except we're going to actually do it with the entire function. We're putting the entire function in, right? So we're going to get 3x, where's it at? Oh, we're plugging in this entire function, all right, into x. So we're going to get x minus 2 all divided by 3. All right, and then we have the plus 2. All right, so we're taking the entire thing, and we are essentially we're taking the entire thing, we're putting it into our function. All right, so we're going to get over here, we're going to get f of x minus 2 over 3 is equal to, well, what's 3 divided by 3? Well, 3 divided by 3 is just 1, so that's gone. So we get x minus 2 plus 2. I'm actually, like before, I want to keep it the same colors. X minus 2, then we get plus 2. All right, well, what's minus 2 plus 2? Well, that cancels. So we just get x. All right, so when we plugged in g of x into our function, we just get x. All right, and that, all right, so that's one part of it. So when we plug in our function, we should get x. Remember, I told you this is my original function right here, this graph that I drew. All right, if it goes this distance here, right up, well, if I plug in my inverse function, right, I'm going back. My inverse function does the opposite, so I'm going back to this line here, which is y equals x. And that's why we get x back, all right, because we're just getting back to the line of reflection. All right, now the next thing we need to do is we need to plug in g. All right, now we have our other function. All right, so if you notice in this problem here, I'm going to scroll down a bit. Okay, we took this function and we plugged it into f. So now what we're going to do is we're going to take our this function and plug it into g. All right, so down below here, I'm going to go ahead and rewrite this as f of x is equal to 3x plus 2, all right, and g of x is equal to x minus 2 divided by 3. All right, let's go ahead. We have our function g. Let's go ahead and plug in f of x into our function, the entire thing like before. All right, so we're going to get g of, well, it's going to be 3x plus 2. And we're going to replace it, all right, like before. This entire thing is going to replace x. Is going to replace our input wherever we see the x. So we're going to get parentheses 3x plus 2, close the parentheses, minus 2, all divided by 3. All right, as you can see, all I did was I took this entire function and I replaced it where there was an x, which was right there. All right, now let's go ahead. This is 3x plus 2 minus 2. Like it before, I want to make sure that I want to keep the colors the same. So 3x plus 2, all right, minus 2, all divided by 3. Well, if we look here, All right, let me scroll down. If we look here, what's 2 minus 2? Well, 2 minus 2 is 0, right? So that's gone. So we're going to get g of, let me go ahead, same color as before, g of 3x plus 2 is equal to, well, we're going to just have 3x divided by 3. Well, what's 3 divided by 3? All right, 1. So finally, we get g of 3x plus 2 is equal to x. All right, so we can finally conclude, since let's go ahead and use one different color. Since f of g of x is equal to x, and g of f of x is equal to x, they are inverses of each other. All right, so we go back up here to our diagram. So if we have our inverse function, which is right there, right? So if it goes down, and our inverse function goes down this distance, we plugged in, hold on real quick, we plugged in f of x into our inverse function. All right, so now we're going back the other direction, the same distance, and we end up back at our line of reflection. So either way, we always end up back at the line of reflection, and this is why, all right, when we plug, we get x for both of them, and that tells us that they're inverses, because we get back to our line of reflection. We get back to what we started with. All right, hopefully this helps to understand how to use composition to solve in linear equations. Okay, think about it.